to compute IP from given PIM, that is mean effective pressure and a given engine operating conditions. The necessary formula may be developed from the equation of the network based on the mean effective pressure and piston displacement. Indicated network cycle is equal to PIM multiplied by Vs Newton meter, PIM multiplied by L multiplied by A Newton meter, because Vs is equal to L multiplied by A. Indicated network per minute is equal to PIM multiplied by L A N Newton meter. Hence, indicated power is equal to indicated mean effective power multiplied by L multiplied by A multiplied by N divided by 60,000 kilowatt. If there are k number of cylinders, then total indicated power developed by the engine IP is equal to PIM multiplied by L A N K divided by 60,000, where IP is equal to indicated power kilowatt, PM is equal to indicated mean effective pressure Newton per meter square, L is equal to length of stroke, A is equal to area of the piston, and N is equal to number of power stroke per minute, that is revolution per minute divided by 2 or N divided by 2 for 4 stroke, and N is equal to capital N for 2 stroke engine. Here K is equal to number of cylinders and N is equal to speed of engine in revolutions per minute. Hence, IP is equal to PIM multiplied by L N K divided by 60,000 kilowatt for 2 stroke engines, and PIM L N K divided by 60,000 divided by 2 for 2 stroke engines. Next is brake power BP. Indicated power is based on indicated network and is thus a measure of the force developed within the cylinder. More practical interest is the rotational force available at the delivery point, that is at the engine crankshaft, also termed as drive shaft, and power corresponding to it. This power is interchangeably referred to as brake power, shaft power, or delivered power. In generally, only the term brake power BP has been used here to indicate the power actually delivered by the engine. The power BP is usually measured by the attaching a power absorption device to the drive shaft of the engine. Such a device sets up measurable forces counteracting the forces delivered by the engine, and determine the value of these measured forces is indicative of the forces being delivered. Measurement of BP using rope brake arrangement. The figure shows rope brake arrangement for the measurement of brake power BP. Rope brake dynamometer. This is a rope brake dynamometer. A rope is wound around the circumference of the brake drum. One end of the rope is attached with the balance as shown in figure. The other end carries the dead weight. The engine is thus run at a constant speed, which is measured with the help of a tachometer. Now, let W is equal to force due to dead weight of the rope brake in Newton. S is equal to spring balance reading. D, capital D is the dia of the brake drum in meter, small d is equal to diameter of the rope in meter. Then capital N is equal to RPM of the crankshaft given by the tachometer. Then work done per revolution is equal to force multiplied by distance, mean W minus S multiplied by 2 pi into capital D plus small d divided by 2 in Newton meter. Work done per minute is equal to Ws multiplied by 2 pi capital D plus small d divided by 2 multiplied with N number of revolution, that is joule. Now, the unit converted into joule per minute. Work done per second, divide the whole question by 60. Now, it is joule per second. The joule per second is called watt. Now, the brake power is in watt. Brake power, divide the whole question by 100. Now, the brake power are come in kilowatt. If the diameter of the rope is neglected, mean D is equal to 0, then brake power is equal to W minus S pi dN upon 60,000 kilowatt. Morse test. It is a method of determining the indicated power IP of each cylinder individually. If a multi-cylinder IC engine without the use of an indicator and thus computing the total IP of the engine by summing up IP of all the cylinders, this method is adopted to calculate IP of high speed engines, that is where the indicator method is unsuitable. Testing of constant speed IC engines for general purposes according to IS 1600 1960. Introduction. This code applies to testing of constant speed reciprocating internal combustion engines of the following type used for general purposes: A. Compression ignition engines, B. Carburetted type engines, and C is gas engines. This code is not applicable to pressure charged engines, engines for road or rail tractions, engines for ships, propulsions or for marine auxiliaries, and engines for aircraft propulsions for aircraft auxiliaries. General requirement for test. The manufacturers shall supply the performance characteristics of the engine prior to the commencement of the test. The engine shall be tested as offered to purchasers. All parts shall be in stock and all parts essentially for engine operation should be included. Accessory used on the engine under test shall be listed. Next, preparation for test. The engine shall be completely stripped and examined physically so that design features and also the conditions of the various parts may be noted before tests are commenced. After the physical examinations, the dimensions of the main working parts listed below shall be checked and recorded. First, cylinder head. Second, valves, valve seat, valve spring and valve guides. Cylinder liners, piston assembly, connecting rod, small and big, and bearings and connecting rod bolts, crankshaft including bearings and journals and governor spring. Preliminary run. The engine shall be subjected to preliminary run of 49 hours at rated speed under the operating temperatures as specified by the manufacturer in the non-stop cycle for 7 hours each, conforming to the following cycles, the period of each run being minimum of 1 cycle. If we apply 25% load, the running time must require 1.5 hours. For 50% it is 2 hours. For 75% that is 1.5 hours. And for 100% rated load, the minimum time required for running time is 2 hours. During the preliminary run, the special attention shall be paid to engine vibration and quietness. The oil pressure shall be checked from time to time. Oil coolant and fuel leak shall be rectified. Faculty components replaced as may be found necessary. A complete record of each attention and running time of the component change shall be kept. Engine test adjustment. It is a test procedure. The distributor, carburetor or the fuel pump rack, as the case may be set as it is nominal specified value at idling in contrast to it is manual adjustment for maximum power at each speed. Temperature. the temperature of the inlet air shall be measured at the entrance of the induction system. Number of runs. In every test, a sufficient number of runs shall be made throughout the speed range. A run shall be made at lowest steady at which the engine operates. Duration of run. The performance data shall be obtained under the stabilized operating conditions. Duration of the experimental run depend upon two principles. Number 1, no data shall be taken until load, speed and temperature have been stabilized. Second is recorded data shall be average sustained value maintained over a period of at least 1 minute with no significant change occurring during that time. Power test. For all power tests with the result to the plotted versus speed, a single series of stabilized runs at ascending speed is sufficient. This series of runs should progress continuously from the lowest to the maximum. If the engine requires to be ideal between runs to avoid successively high temperature, the sufficient time should for the engine to reach its stabilized conditions before taking reading. The brake fluid recorded should be steady and constant throughout the run. Engine speed. The engine speed should be held constant as possibly by means of applied dynamometer load at wide open throttle or by throttle adjustment at part load. Friction power. The friction power test shall if possible follow immediately after the power test. If this is not possible, the test shall be conducted under the condition similar to those for the power test. Fuel consumption. The fuel consumption shall be measured simultaneously with brake power. The fuel consumption measurement shall not be started until the engine is stabilized. Observations. Observed brake power is given by the formula brake power is equal to Ws multiplied by 2 pi capital D plus small d divided by 2 into N 60 multiplied by 1000 kilowatt. Mechanical efficiency is equal to BP upon IP. Indicated power is equal to BP plus FP. The specific fuel consumptions. The specific fuel consumption shall be computed on the basis of the gram of fuel per observed brake power hour. 500 hour endurance test. After completion of the performance test, the engine shall be run for 500 hours at rated speed in cycle of 16 hours continuously running, each cycle being made as follow. Recheck of power and fuel consumption. The power fuel consumption shall be determined by repeating the performance test. Final inspection. As the conclusion of the test, the engine shall be stripped, its condition noted and the dimensions of the main working part checked and recorded. Thank you. And please note the assignment of related topic. Question number 1, explain the following term: engine continuous power, indicated power, brake power, specific fuel consumption. And second question, what do you mean by indicated thermal efficiency, mechanical efficiency, volumetric efficiency, overall thermal efficiency? Thank you.